All right, hello everybody. I want to take a little bit of time to talk about probability, some of the vocab, and do a few examples. And hopefully you can check out some of the notes and the PowerPoints or your textbook, in addition to just watching the video. So let's just jump right in with some scenarios. Most probabilities have to do with some type of event. And usually that event is defined for us. You know, it could be rolling a die, flipping a coin. But let's just say for now the event is having two kids, having two babies. So having two kids. So the idea is that the first child comes and it's either a boy or a girl. And, you have a 50% chance, so to speak. And we call this an outcome. But if you're having two kids, or your family's growing or something, the idea is after you have that boy, you could have another boy, or you could have a girl. And if your first child was a girl, the second child could be a boy, or it could be a girl. We're listing out, combinations. And so when you think about all of the possibilities here, there's something called the sample space that comes up. And the sample space is the list of all outcomes. So for the particular event of having two kids, you could have a boy and a boy. I'll represent that with BB. You could have a boy first and then a girl second. You could have a girl first and then a boy second. Or you could have a girl first and a girl second. Those are the combinations, and they make up the sample space. This thing up here is called a tree diagram. Sometimes you use it when you're finding factors in a math class or something. But when you look at this particular branch of the tree, that represents one of the possible outcomes. And so we got the sample space there, we got the outcomes, we got the events. And what's going to eventually happen, we'll come back to it, is you're going to be asked questions like, what's the probability of having, exactly, two boys or something. And just kind of getting you ready for that, the idea is that there's one combination of two boys out of four, there's my four total possibilities. And so sometimes it's very nice if you have a tree diagram or a sample space. You can think of the sample space as the denominator. So it's kind of a nice visual to have. It can become a little bit gnarly if you got something that has a whole bunch of outcomes. But for now, that's some of the vocab, and I'm going to move forward to another example. So let's say we're at In-N-Out Burger. We're trying to decide what we want to eat. And so let's say that there's, you can either get a cheeseburger, you can get a hamburger, you can get a double-double. And then it's not on the menu, but if you ever had it, it's actually pretty good. You can get a grilled cheese. And so you can think of these kind of as the sandwich options. Your main course, so to speak. And then when it comes to your sides, you can get fries. Or, you can get animal fries, which are really good but kind of expensive. And so, if we labeled this as a category, you can think of this as sides. And then if you want to get a drink, I'll write it down here. You got your drink options. And there's lots of different fountain drinks, but let's just say that, you could get a soda if you want, or you can get a milkshake. You can actually get coffee too, depending on what's listed on the menu. So the question then becomes how many options or how many options, how many combinations do you have for lunch? And if you list the whole sample space, it can be quite the endeavor. For example, this will hopefully come pretty quick. One option is you could get, a cheeseburger, animal fries, and a milkshake. That's one option for lunch. But another option would be, I want to get a grilled cheese, animal fries, and a soda. Another option would be, I'll switch colors again. I want to get a hamburger, regular fries, and you know what? I need a little coffee boost. And the idea is there's a lot of, combinations. You can think of options as combinations. And this introduces kind of the main theme for this section, which is called the fundamental counting principle. And it's a very fancy word that represents kind of a quick way to find all of the combinations and the options. And so here's how it works. If you think of this, and this is kind of a theme throughout this this chapter, if you think of this as kind of three events, you have kind of event 1, event 2, and event 3. And in each event, you want to think about, well, how many options are there? And in the first event, you got to pick your burger. You got 4 options. And in the second event, you got to pick your side. And according to my menu, you got 2 options. And the last is, you pick your drink. And you got 3 options there. And so instead of having to list out all these stars and make a tree diagram and list out your sample space, the idea is if you multiply 4 times 2 times 3, you get the answer. There's 24 options or combinations for lunch. So that's kind of an example of the fundamental counting principle. Let me kind of do another one for you that's a classic question. So if you think about the license plates on cars, there's lots of combinations, lots of cars out there. And in California, I believe, you got 7 spots. So you can think of each one of these spots as a different choice. Different states, that usually smaller states, some states only have 6 spots, or, I'm not sure if any have 5 spots, but I know we have 7 spots. And there might be a certain thing that has to go in here, but let's just say, for instance, this spot has to have a letter. Let's say this spot has to be a digit or a number that's 0 through 9. Let's say this also has to be a digit, another digit. Because I know all the combinations, I'm not sure of the restrictions, but you got a sequence of letters and numbers. And then let's say, these are also letters, A through Z. And then let's say this one, mix it up a little bit. This could be a letter or a digit. And before we even do this, that there's a ton of combinations. I mean, there's a ton of cars out there. Some of those old cars, they don't want to give the same license plate to a new car. They got to be unique. And so what I mean, letter, digit, according to my little schematic up here, if I had A934 TV8, this has a letter, 3 digits, letter, digit. That's an example of a license plate. And so the question I have to ask you then is, how many combinations or how many license plates are possible And so the idea here is the fundamental, I can't say that word for some reason, the fundamental counting principle. And to figure out, well, how many options do you have for each event, or in this case, each space? And then we can multiply those together. And so, when you talk about letters A through Z, if you forgot, there are 26 letters in the English alphabet. You know, A, B, C, all the way to Z. And so there'd be 26 options here. Digits 0 through 9, you know, you got 1 through 9, which is 9 digits, but you also could have that number 0. And so there's actually 10 options for digits. 10 options for digits. And so you got, you know, 10 times 10 times 10, representing all the options. And then, again, you got 26 letters. And then this kind of introduces a thing that we'll look at a bunch in class. But if this could be a letter or a digit, the idea is you got 26 options for A through Z, but you also got 10 options for 0 through 9. And so there's actually 36 different things that could go here in that last spot. And so if you wanted the total number of license plates, I don't have my calculator handy for this screen capture, but the answer is going to be a really big number, because you're going to have to do 26 times 10 times 10 times 10 times 26 times 26 times 36, and that will spit out the answer to this question. All right, let's do one more to make sure it kind of makes sense for us. Let's say we got the same thing, but we want to know, let's say you how many 4-digit passwords are available. A, where repetition is okay, or, you know, repeats are allowed. And then we'll do a second version of it where repetition is not okay. So you guys have had to create passwords for all sorts of stuff, and sometimes it has restrictions. You know, whether you have to include a capital, or you have to include a symbol, or it has to be at least 7 digits or something. So this is kind of a variation of that, but a little bit more simple. So 4-digit passwords means there's 4 events. I like to draw little hash marks to represent the events, and then above each hash mark I put how many options there are. So this first one, if it's 4-digit, we got the digits 0 through 9, and it says that repetition is okay. Well, that means that I got 10 options in the first spot. You know, it could be 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I still have 10 options here, 10 options here, 10 options here. You know, this would be a legit password. This would be a legit password. This would be a legit password. Repeats are okay. That's what that means. But you're going to start getting into somewhere, you know, repetition is not okay. And we'll end with this in our first video. And so, you know, when you think about having the first option, you've got 10 possibilities, you know, 0 through 9. But once you pick that first possibility, let's say your first digit is 9, well, then your next digit can be anything but the first one. And so you're actually going to have just 9 options. What I mean is, if this was like an example, you know, if 8 was here, then you could have a 0, 1, 2, all the way up to 7, and you could have a 9, but you couldn't put an 8 there. And that's why it's going to decrease. Repetition is not okay. Once you have that, you're going to kind of repeat that idea. And you're going to end up